Hi folks, today we're going to focus on the graphs of these polynomials that we've been working on, and in specific today is just end behavior and turning points. So one real quick fact to focus on is that the graph of a polynomial function has one fewer turning point than the degree. Now, going back to some of our vocabulary, the degree of a polynomial, all that is the biggest exponent. So if we take a look at what we have with these three polynomials sitting here, this first one, f of x equals x squared plus 1. So if we focus on where that biggest exponent is, which is right there, it's x squared, what that tells us is that we are going to have one turning point in the graph. Okay, so one turning point in the graph basically means that the graph is going to change directions one time. So it's going to look like a parabola, some of those things that we've worked with in the past. Moving on to the next one, g of x equals 3x cubed minus 4x plus 6. Again, we find our biggest exponent, and it's to the third power. So that third power is the degree, which means our number of turning points is one less. So this is going to have two turning points. So this graph is going to look something like this. And again, we go to the h of x, negative 2x to the fourth, minus 6x cubed, minus 11x squared. Our biggest exponent is fourth power, so it's going to have three turning points. So our graph of this would look something like an M. So again, find the degree, which is the biggest exponent, and the number of turning points, or number of times the graph is going to change directions, will be one less than that. The next thing we're going to focus on is what I like to refer to as the end behavior. And the end behavior is basically referring to what is the left hand and right hand, or left end and right end of the graph going to do. Now, that's all related to, as it says here, the leading coefficient and the degree. Now, this is straight out of your book, and if you pay attention to it, it might confuse you a little bit. So I'm going to try and make things a little bit easier for you. First off, I'm going to focus on these top two where we have an odd degree. So if we have x to the third, x to the fifth, x to the seventh, something like that, then we know that we're going to have the left end and the right end going in opposite directions. But which side is going to go up and which side is going to go down is going to depend on the leading coefficient. Now, we've practiced finding leading coefficient, and that's just the number that's out in front of the biggest exponent. So if that biggest exponent is positive, then the left end will go down, right end up. And if the leading coefficient is negative, left end up, right end down. So instead of trying to memorize all these different possibilities, I would just ask that you memorize what x to the third would look like. X to the third, that graph is going to look like that. So then, if we think back to the last page, we have degree 3, which means 1, 2 turning points. So a positive x to the fifth then, the left end would still be down, the right end would still be up, but we think about how many turning points are going to be in there, and it's going to be 5 minus 1, or 4. So the graph would look something like that. Okay, now if we make these negative, so a negative x to the third, then the graph is just going to basically flip itself around. Same thing with a negative x to the fifth. The graph is basically just going to flip itself around. So that's what happens with odds. If you remember what happens with an x to the third, just remember this. Then you can apply some of the other things that you already know to the graph. What happens if you go up by another odd exponent? All it does is add a couple of turning points. What happens when the leading coefficient is negative? The graph just flops. Now you can do basically the same type of thing with even degrees. So if, again, the degree is even, both ends are going to be going in the same direction. It'll look like either a W or an M, or some of those parabolas we've worked with. And if the leading coefficient is positive, both ends are up, it'll open up. If the leading coefficient is negative, both ends will open down. So again, if we just try to remember what happens with a positive x squared. It looks something like that. And if it's negative, it'll just open down. If we go up by a couple of degrees and make it positive x to the fourth, we should know that we'll have 3 turning points in there. And if we have a negative x to the fourth, it'll look more like an m. So here, if we were to practice some of that, we're going to just look around for the biggest exponent. We want to explain the end behavior and turning points of each graph. I think you can just draw a picture on this and you'd be okay. So this first one, f of x equals x cubed minus 3x squared, we take a look. X cubed is our biggest degree. So we know that the ends are going to go in positive or in opposite directions. And since the leading coefficient is positive, right end is up, left end is down. And how many turning points in there is going to have 3 minus 1, or 2 turning points. So the graph is going to look something like that. All right, if we go over to this next one, our biggest exponent is 4th power. All right, so we know that both ends are going to go in the same direction. Now we need to determine what direction that is, up or down. So we're going to look at the leading coefficient, and the leading coefficient is negative. So both left end and right end will be going down. And since it's 4th power, we know that we will have 3 turning points. So there it'll look something like that. This next one, biggest exponent is 5th power. So our graph is going to be going in opposite directions, but since the leading coefficient is negative, we know that the left end will be up, the right end will be down. Biggest exponent is 5, so we know we're going to have 4 turning points. So it'll look something like that. And this last one is a positive x squared, and that's one of those things I would ask you to memorize. It's a positive x squared, just looks something like that. Now this is something that's going to take practice. You need to make sure you know what your vocabulary words are in terms of degree, leading coefficient, exponents, things of that nature. So you definitely need to practice this. So on page 342, I want you to do numbers 25 through 36. And despite what the directions say, only do the end behavior and turning points. Okay, so if that means drawing a picture, go for it. All right. So best of luck to you. We'll see you in class.